Welcome back, guys. So this is question 2.17. So this is the figure P2.17, and from this figure we have to find what the part A of it is. Find V naught using Kirchhoff laws and Ohm's law, and B is test the solution for V naught by verifying that the total power supplied equals the total power absorbed. Okay. So in our previous video we have seen the use of the Kirchhoff laws, the Ohm's law, and today we are going to implement it here in this circuit. Okay, so first of all let me see that what is here. So you can see that the current which is here, this is, let me call it I naught. When it reaches this junction which is here, it splits into two direction. The first one, let me call it I2, and this one is I1. Okay, so applying here KCL, so according to the KCL, the first equation here is I naught is equal to I1 plus I2. Okay, so this is the KCL here. Similarly, here in this branch only we can apply the Ohm's law, and here V naught is equal to what? That is I1 into R, and the value of R is 5 kilo ohm. So this is 5 kilo. Okay, let me call it equation 1 and this equation 2. Okay, the third one here is, let me consider this overall branch. Okay, this branch, let me identify it by using this overall branch. Okay, and here applying the what? Applying the KVL. If we call the voltage drop across this one as plus minus V2K, okay, and the voltage here is, let me call here, this is V naught, okay, because this is given, and this is V2K. So applying the KVL here, what will we get? V naught is equal to the voltage drop across this one which is V2K. Okay, and here you can see that this is as that of the same polarity as here we have this V naught, because here if you see, this is here, this is minus plus 5 volts, this is V2K and V naught. Okay, so the V naught here is positive, means that it is connected to this positive terminal while this is the negative terminal. Or we can also represent it like what? It can also be represented like plus minus, which has the same polarity as that of this one. So therefore here from this one it will be subtracted because it is of the same polarity as that of V naught, so it will be minus 5 because of this 5 volts. Okay, in a single equation it is obtained from a single equation where we had V naught plus 5 minus V2K. Okay, that is equal to 0, and that is the KVL. From this equation, ultimately the equation we got is here, this one. Okay, so let me call it equation 3. So now we have three equations, 1, 2 and 3. Okay, so in this equation the value of V2K is what? We can see that here this is I2, and I2 is moving through this resistor and giving us what? Then it is giving us the voltage. So therefore the value of V2K is I2 multiplied by 2K. Okay, so the value of V naught here, let me solve it. The value of V naught here is what? That is I2 multiplied by 2K minus 5. Okay, similarly the value of V naught, as we have seen, that has also the value which is here. So comparing this equation, let me call it equation 4 and 2, what will we get? Comparing them both, because the left sides of both of them are equal, so here we will get this. This is 5K, so 5K means 5000. So 5000 multiplied by I1, that is equal to, this is 2K means 2000. So 2000 multiplied by I2 minus 5. Okay, or ultimately we can also get it like moving this to the other side, 5000 I1 minus 2000 I2, that is equal to minus 5. Let me call it equation 5, and that is equation we have. Okay, so now we, which are here, the first equation is here, the second equation is here. Okay, so here in these two equations, let us compare them, and comparing them we have to put the value of I naught here as well, and using the similar color here as well. So the value of I naught is 20 milliamperes, so that is 20 into 10 to the power minus 3, that is equal to I1 plus I2, and let me call it equation 6. So now we have here this equation and equation 6, and we can find the values of I1 and I2 from those equations as well. Okay, so let us move down somehow. Okay, so as we have this equation, so let me multiply 2000 with this equation 6. What will I get here? On the right side we will get 2000 I1 plus 2000 I2, that is equal to, multiplying it here at this side, what will we get? This is 10 to the power minus 3, so it will be cancelled out and we will get here 2 only, so ultimately we will get 40. Okay, again we have this equation, so let me write this equation here as well. So let me write it here. So it will be 5000 I1 minus 2000 to minus 5. So let me add both of these equations. So adding them together, these two will cancel out, and here we will get 7000 I1, that is equal to 35. From it, the value of I1 will be 35 divided by what? Divided by 7000. So it will be this 2. So 1 over 200 amps. Okay, so this is what, this is the value of I1, which is the current here. So now in order to find the value of V naught, we have this equation number 2. Let me use this equation number 2. So the value of V naught will be equal to the value of I1, which is 1 over 200 multiplied by 5000. Okay, these two will cancel out and ultimately it will be here with this one. So the answer of it is 25 volts, which is the value of V naught, and that is the solution of part A of our question. And in this part we have seen that how to find out the value of V naught using the Kirchhoff's laws and Ohm's law. In the part B of it, as the solution for V naught by verifying that the total power supplied equals the total power absorbed. So what are the powers which are supplied? So here we can see that this is positive, this is negative, here this is negative, this is positive, so therefore the polarity opposite of it, so we will put the negative side with it, and we will write here V multiplied by I for finding the power here. Similarly, you can see that here this is negative, this is positive, while the polarity here again is positive, negative. So therefore, as this one is also the source, so it will be minus V into I. The value of I is known, which is I2. We will find them out, and then from both of these two we can find out the value by P equal to I square R. The values of I are known and the values of R are also known. Here the value of I is I2, here the value of I is I1, both of them are known. You can find them easily. If you don't know from this formula, you know the I1, you know the I naught, you can easily find out the value of I2 as well. Okay, today we have seen that how to find out the V naught and also how to find out the total power, because here once you will find the total power developed and total power absorbed, you will see that both of them are equivalent. So if you will have any ambiguity or any difficulty in solving the question like this one, or you have any difficulty in solving part B, please let me know. I will solve it again. So that's it for today. If you have any question, you can ask me in the comment box. See you soon.